measures of central tendency. Although for any variable which is quantitative in nature, which is numerical in nature, it is required that you generate both the central tendency and the measures of dispersion or measures of variation. For mean, the relevant measures of dispersion is standard deviation. For median, it is range, that is minimum and maximum values plus interquartile range. So when do we have to present the mean only, and when do we have to present the mean and median both? Because mean is the main measure of central tendency that we have to present in our publications or in our presentations. However, sometimes mean may not be the right measure of central tendency to display, and there are other measures such as median, which is more appropriate than mean. Beside mean and median, there is another measure of central tendency which is called mode, and mode is about the most frequent element in your series of data. Most frequent, most fashionable, most repeated. So all right, so for this lecture, we have studied these concepts before regarding what is biostatistics and the uses of biostatistics and the role of biostatistician, and then we discussed the measures of central tendency and dispersion. So I'll go directly to that fourth objective to remind you. So right, so for variables which are on a scale such as height, weight, blood pressure, systolic blood pressure, diastolic, hemoglobin percent, platelet count. For all these variables, you can calculate mean or other measures of central tendency. So right. Why mean is important to be presented in any data? Because we need to look at the core thing. We'll need to know what the data is all about. For example, if you are talking about age variable, age in years of a group of people or group of children, babies, or whoever, we need to find out what is the average age of that whole series of participants, so that we can have an understanding which group of people, what age group of people we are dealing with. For example, if most of the participants are of age 20 and 22 years, and a few are 23, 24 years, a few are on the lower side like 20 years. This distribution can be considered as normally distributed because there are no outliers, and all the observations, most of the participants are in the 20-22 years age range, and a couple of are 20 or 19 years, and a couple are above the 22 years, 23 years. So this distribution can be considered as normally distributed. However, what if in the same distribution there comes a participant who joined the group by mistake, maybe, who is 40 years old? Then the whole distribution will be skewed to the above side because of that higher age, above age participant. That higher age participant pull the whole distribution to the right side. While similarly, if we take another example for the same distribution, where instead of a 40 years old gentleman join the please wait for a minute. इसको कंफर्म करो, ये बिल्कुल ठीक चल रहा है, वहां से देखो और मुझे कंफर्म करके बताओ। और वैसा आया था किस चीज का मैसेज?
जी सर, सर
वेट
वैसे ही
मिनट।
बोलना सर, आसान
ओके
सर।
वैस वैस
सर मैं
इज
आप
इट ऑल गोइंग
बिल्कुल
फाइन?
सही है, बिल्कुल
ओके
सही है,
थैंक यू,
बिल्कुल। मैं
सही है,
सर
थैंक यू
आपके
वेरी
साथ
मच।
ही हूँ सर कब से।
ओके थैंक यू, बस सही है। अनीस तुम वहां से ज्वाइन कर लो, इधर उधर नहीं होना। ऑलराइट, थैंक यू वेरी मच। So we were talking about, instead of a 40 years old male joining that distribution of 19 to 22 years old participants, instead of a 40-year-old participant joining that group, a participant by mistake joined the group who is just 10-year-old, a child. What will happen then? The whole distribution will be pulled to the lower side, and that distribution will be considered as negatively skewed or skewed to the left. So both of the distribution which have been skewed either to the right side or to the left side are not considered as normal distribution. And in both of the distribution and both of the cases, presenting just mean as a central tendency would be an error or would be a mistake. And most of the uh, all the journals which follow the uniform guidelines, they will not accept your paper if you just present the mean for a distribution which is not normally distributed. So here a question arises. Some students may ask that how come the journal know that the distribution was not normal? So it is the responsibility of the author and or the researcher that to let the reader know whether the distribution was normal or not. And now you can see that in any research study there would be multiple variables, multiple quantitative variables to display. And uh, uh, do we have to present the normal distribution thing for all the variables? Maybe not, but at least for the main variables. For the main variables, maybe for the main outcome and the main risk factor at least, right? So these three things, the mean, median, and mode, are the heart of the distribution. However, mean is affected by extreme values as we discussed, and for all skewed distribution, we should not rely on mean only. We should present the median as well. All right. So there is a question which is relevant by by student Nurul Ilma Hassan, that should one give all the measures of central tendency in an article? No. The answer is, if you are happy with the mean only and your distribution is conforming the normal distribution elements, then you don't have to present the median and the mode. If your distribution is not normal, you must present the mean with median and the respective measures of dispersion, which is, as I said, standard deviation for mean and range for median. Mode is not necessary. However, if in cases where you are presenting in the, so for example, you are doing a study in the outpatient department, and the objective of the study is to explore and to determine the various types of diseases from January to December in a calendar year in a particular area. And there some of the diseases will some of the diseases or some of the patients with those diseases will repeatedly come to the OPD. And in that case, a mode would be very helpful. And in most of the instances, mode is not required. However, if you want to present the most repeated element of certain variable, then you can present mode, right? In the business analysis, or maybe health management or health administration domain, mode may be frequently used as compared to in the clinical sciences. Clinical sciences, mean and median are most frequently used measures of central tendency, right? So this is not today's lecture, the measures of dispersion or variability. So we discussed this. What? We discussed the mean and median before in the previous lecture. Now, what is this central tendency that I was talking about? The central tendency is that if a variable is following the normal distribution curve, then we can predict within one standard deviation above and below the mean how many observation can be captured. Because most of the time, and all of the time, a researcher is doing research on samples, not on the whole population. So when we are except in census, Adam Shumari, Mardam Shumari, except in census, we do all the research on sample of patient, not whole population. So a sample of population uh, can give us a prediction about the whole population. So if the whole population is, for example, Karachi's population 20 million, 2 crores, so we can take a sample of, for example, 200,000 out of those 20 million and can infer on the basis of that sample. And that sample, if that sample is correctly approached and representative of the whole population, and we did everything right, our methods were right, then we can, within 2 standard deviation, then we can extrapolate our findings or generalize our findings onto the population with 95% confidence. So today's lecture is not about just discussion and looking at the slides. So you may be happy that we have here SPSS available, and in the SPSS, what I'll do, I'll share my screen and demonstrate you what we can do, how can we play with this SPSS. Now you know, that what SPSS stands for. I'm not going in the detail of what is SPS and how does it work, but can you see the interface of SPSS on your screens? A simple yes or no would be yes. Thank you very much, Ahmed Ali and Nuru Elma. So there are 16 participants in total, I think, including myself and my moderator, Mr. West. Thank you very much. And maybe Anis has joined us as a moderator. So I think 13 or 14 students are attending this lecture. This is kind of shame for me, but we'll continue with this important skill for data analysis. So in the data analysis, you must have data. As you can see on the screen, I have a very rich data available. The name of the file is mop.cvd. So it is a real data. The real data collected from Civil Hospital Karachi after full IRB permission and approval from the respective department, and of course the college, Dow Medical College. So you can see it is a rich data starting from the serial number till the creation of systolic blood pressure variables. So this is the data view, and in the variable view you can see. Can you see the variable view here? Time to time I'll ask these type of questions to make sure that you are with me. Thank you very much. Just a simple yes or no is fine, perfectly fine. So on this in this variable view, you can see there is a variable serial and the timestamp because we collected data in real time, and that was electronically collected data. We did all the data collection using smartphones or tablets while working in the outpatient department and in a paperless environment. So it was, I think, one of its kind first study done in the Dow Medical College, which was conducted through paperless data collection. So now you can see this variable age, and this age is a numeric variable, obviously, and this age is on scale. Obviously, the age must be on scale because whichever variable is on scale, you can subtract meaningfully, add meaningfully, apply arithmetic operations such as calculating mean and other things. So that was required. However, in case of gender, gender here is again numeric because we have to code it as one female or two male, but the measure of gender variable is nominal. It is a nominal. Obviously, gender is nominal variable. Some variables could be ordinal, but if such thing arises, I'll let you. All right. So we'll see what we can do with this age thing. First, what is the age of our participant? Let's see here. The age started from, if we sort it ascending and descending. So this data was collected from the internal medicine outpatient department, medicine OPDs, and the purpose of collecting this data was to determine that how many patients coming to the medical OPD have not, the risk factors positive for non-communicable diseases. Non-communicable diseases are which diseases? Which are chronic in nature, and the examples of those diseases are diabetes, hypertension, maybe stroke, high blood pressure. So many multiple diseases. So we were looking at the risk factors of those diseases among these participants. So we had as low as 15 years old candidate in the medical OPD. If you ask me that 15 is a minor age group, so I agree with you. But in the outpatient department, what we have observed in reality that there are certain mothers, females, who are married, already have a baby, and still they are so young that we can classify them in the minor age group because they are now they are considered as a mature person carrying a baby and other things. That's why we included them. So those were not many people below 18, just 4 people. So the minimum age group we had was 15, and the oldest person in our series was 77-year-old. So let's see what we'll do. We'll first run frequencies for this age. What we can see here? We can see here that we have a total of okay, right, this screen is not shared. So now can you see the output screen? Yes. Okay, thank you. The output screen is now shared with you, which shows the frequencies that I just run here. So you can see the valid number of cases were 359, and there were no one missing. Nothing was blank in the age variable. That means we have a full data set of 359 patients. The mean age of this whole group of 359 patients is 41.88 years. Meaningfully, we can calculate mean for age. And the median was 40.00. When the mean is larger than median, what it denotes? लास्ट लेक्चर में मैंने ये आपको शेयर किया था कि अगर मीन मीडियन से बड़ा हो तो इसकी क्या इम्प्लीकेशन है. Ideally, mean and median must be same or similar, closer to each other in a normally distributed data. But when the mean and median are farther apart, that means the data is not normally distributed. So what you can say here, someone commented here, positively skewed. Yeah. So our data is positively skewed, but how much? 1.88 years, not much. But let's see. And the standard deviation, because it is calculated by default whenever we run descriptive or frequencies. So the standard deviation was 12.2 years. Is it high or low or what? We can tell about the standard deviation by looking at range also. So the range of for age in this data set was 62. The minimum was 15 and the maximum was 77. So yes, now we can say, because our data is trying to capture two extremes, as younger as 15 years old and as older as 7-year-old, that standard deviation is a bit on the higher side. Although nothing is lost, ऐसा नहीं है कि हमारा डेटा बिल्कुल कोई खराब हो गया है, but this standard deviation is a bit on the higher side. Just remember the numbers here, and we'll see 41.8 and 12.2. And I'm sharing with you another thing, the whiteboard, right? So you can see the normal distribution, not a perfectly normal distribution, but I tried to make a normal distribution curve, right? Can you see the whiteboard here? Hello? Yes, thank you, thank you, thank you very much. All right, so here we can see if these black lines are for one standard deviation cutoff, imaginary line, and the blue line is for the second 2 standard deviation, and the green line is for 3 standard deviation. So within what should I do? So this is one standard deviation, this is one standard deviation on the negative side. I'm sorry, the choice of the marker was not good, so I'm changing it to the different thing. So this is the one standard deviation below and one on the above side, one positive, one negative. This is the 2 standard deviation for this distribution on the negative side, and this is the on the positive side. Similarly, this is the third, and this is the third on the negative side, right? Now, all right, and first, right. So within 2 standard deviation from here to here, which I'm trying to fill with blue color, This whole area is captured within how much standard deviation? 2 standard deviation. Using the central limit theorem, the central limit theorem says that within the 2 standard deviation, you can capture 95% of the observation if the data is normally distributed. This is something very, very amazing. This inference or generalizable comment is very important. If you can capture 95% of the observation within 2 standard deviation, 2 standard deviation below and above the mean value, that means you can infer about the 95% of the captured population, captured sample, and on the basis of that sample you can infer about the population. So our mean was going back here. I think maybe it's better. So हमारा mean कितना था? Mean था 41.88 and हमारी standard deviation कितनी है? Plus कितनी है? I think 12 point something थी. 12.2 थी. So 12.2. If we add these values, 41.88 and 12.2 are added, then it will become what? 2 is added, then 42, 44, and 54, right? On the above side, it would be 54. And on the below side, what it would be? Just calculate it. 41.88 minus 12.2. So I'll do this calculation here on my calculator. 41.88 minus 12.2 equals 29.68. 29.68. Right? And this is about my date. This is about 1 standard deviation. So within those first black line above and below, what age group would be there? Would be 29, as low as 29 years, 29.68 years, and as high as 54 years. And how many of those will be? 68%. What if we are talking about 2 standard deviation? Then we have to do this thing like 41.88 plus we have to double it, this thing 12.22 को double करना पड़ेगा. So 12.2 multiply 2 equal 24.4 plus 41.88 equals 66.28. Right? 66.28 is the above side. And again on the lower side it would be 12.2 multiply 2 equal 24.4 minus 41.88 equals 17.48. 17.48 comma. This number is telling you that within the 2 blue lines, the shaded area, we have captured 95% of the observation, and we are sure that the age won't be less than 17.48 and won't be higher than 66.28 within this captured area. And those are 95% of the observation. And we can extrapolate on the basis of this central tendency what we have calculated with the help of standard deviation, because a central tendency itself may not mean anything in your clinical sciences. So it would be better to incorporate the measures of variation to make it understand. Although this lecture is about only measures of central tendency. So this 17.48 and 66.28, the lower and the above age values, what these are showing? These are showing that if we have taken a representative sample from the civil hospital OPD, medical OPD, during that part of the year, जो जिस टाइम पे हमने ये स्टडी कंडक्ट करी है, इसका मतलब है कि आप हमारी ओपीडी में अगर आप दोबारा से भी ये सर्वे करते हैं तो आपको यही एज ग्रुप मिलेगा। हमारे ओपीडी में आने वाले जो मरीज हैं हजारों की तादाद में, मे बी a bit 100,000 ओवर द ईयर, तो वो जो है वो इस एज ग्रुप को बिलोंग करते हैं। कितने परसेंट? 95% तक लोग इस एज ग्रुप को बिलोंग करते हैं मेडिकल ओपीडी के। इन केस वेयर वी आर श्योर कि हमारा डाटा रिप्रेजेंटेटिव है, और to a good extent I'm sure, right? So there are questions. All right, all right. So could you please repeat how we inferred that these will cover some 95% of the data from there? Okay, I'll show you in a minute. Give me a minute and I'll show you another picture. Where it is there. I'm gonna share with you a different presentation where we can see the. All right, there. And right. Can you see this graph here? Here, please. Can you see this chart here? Yes or no? Yes. Thank you, Ahmed. Okay, so this chart. So based on a theorem, you know about theorems. Theorems, what we studied in our matriculation examination, or maybe in the OA levels. Theorems are based on certain assumptions and theories, and those theories are valid and tested, and can be used for inferring about populations or some other things, such as in the engineering we make um, different inventions or different constructions based on those theorems. And a similar theorem is central limit theorem, and that central limit theorem says that the mean in a perfectly normal distributed data, the mean, mode, median will all three will lie on the same plane in the center, in the zero level of this distribution. And on the right and left side, obviously, if the central tendency is in the middle, on the right and left, the flanks would be variations or the dispersion, and the dispersion can be seen having a middle hump. You can see a middle hump, and then a slope, a gradual slope which ends, or which not ends but which continue with the horizon, the horizontal line, the baseline, which continues with the baseline and doesn't touch the baseline. If it touched the baseline, that would mean कि आपने जो है 100% observations को capture कर लिया. So in the science of statistics, nothing could be 100%. So there is no such thing in reality where we can say कि 100% कोई चीज exist करती है. We cannot estimate or calculate anything in this world or in this universe with 100% certainty. So we can only calculate things up to 99.99999% certainty. In practice, a certainty level up to 95% is sufficient for for operations or for procedures such as the clinical sciences endeavors, clinical sciences pursuits. For example, you just need a 95% research confidence level while doing any operation, any surgery, any other drug administration, or looking at the adverse effects. So in the clinical sciences, 95% is acceptable cutoff where you can work on, right? So according to the central limit theorem, the mean mode median is in the center, and in the flanks, we can distribute the right and the left flank into three distinct parts. The first part is starting from the middle to the one standard deviation. It is called one standard deviation, and it captures 34.13% observation. An identical part would be on the left side. That's called the negative one standard deviation. And cumulative -1 up to -1 till +1, there would be 68.26% observation will be there, right? So this is the normal distribution curve that I was talking about. Again, from one standard deviation up to two standard deviation, there would be a constant number of 13.59 or 13.6% observation will be captured, and this is identical on the left side as well. If you sum up all these 13.59, 34, and 13.59, you will get 95%. So you can do it. 13.6 would be 27.2 plus 68.26. It will give you 95%, 95.46 or 95.5%. What it's telling you is telling you that within the -2 standard deviation up to +2 standard deviation, how many observations are captured? 95.47% observation. And this is the case of normal distribution. If in your own data, if you get the normal distribution yourself in your own data, and you can get the normal distribution for quantitative variable, mind it, for variables such as age, height, weight, other physiological data. So for those variables, those which can be normally distributed, if you get the normal distribution in your data, in your series of data, that means your data is following the normal distribution curve, and the central limit theorem principles can be applied, and you can infer easily on the basis of that. Okay, so I'm going back to my SPSS thing to let you see what was happening there, right? So this was the statistic that we produced, but we didn't do the chart making. So now we are doing the chart making. For what? Age. And I'll do, because I have just 10 minutes left, so I'll do everything together: height, and maybe BMI, and maybe systolic blood pressure, and maybe diastolic blood pressure, so that you can have a rich experience of looking at. So when you are where you did go, I'll show you once again at the end. So we went to the frequencies and put all the variables where we can calculate the mean and median standard deviation as well on the right side pane, and then we click the statistics and click whatever we desired here: standard deviation, range, minimum, maximum, standard error of mean, right? And then we form certain charts. Which chart is applicable for numerical type of data, quantitative data? Histograms are applicable, and you can see it gives you an option that would you like to see the normal curve on histogram? Yes, I would like to, and I'll click continue, right? and then we'll hit OK. So I'll show you once again. Where did we go? We went to analyze descriptive frequencies. Then we went to the variables with whatever required, for example, this, and put it there on the right hand side. Age, height, weight, BMI, systolic and diastolic blood pressure, all are quantitative variables. Then we click the statistics and and check all those that are required. Click continue and then click OK. And then when we hit the OK button, we will get this. The age variable, first you have to check that you don't have a missing value. So you don't have, I don't have a missing value here. I have full 359 participants for all age, weight, height, BMI, systolic and diastolic blood pressure, while it has calculated the mean for me. For age, the mean is higher than median, so it is right skewed. For weight, you can see it is a bit skewed onto the right, but not much. Median is 71 and mean is 71.22. So we are better off here. Again, in the case of height, the height is quite close to each other. However, in the case of BMI, you can see the BMI, the mean is lower than median. So it is negatively skewed. And for the other things, you can see, right? Both systolic and diastolic blood pressure are a bit positively skewed. For the age, the frequency tables are there. I'm not going into the details of the frequency tables. It will grab our time, but I'll show you what this is. Can you see the histogram here? Hello, a histogram? Yes, sir. Thank you very much, Rima. So a histogram is being displayed on your screen, and this histogram was constructed for age variable. And you can see the mean age was 41.88 years, standard deviation. The count of standard deviation was 12.191, and the total participants were 359. We can see here this data is to a very good extent, it is beautifully conforming or following the normal distribution. It has a big hump in the middle, which shows that most of the participants are, that's the mode. Most of the participants are of what age? 42, I think, 41, 42 age participants. We'll see in the normal distribution what a mode we got. So, however, एज के केस में आपको टेल कहां पे नजर आ रही है? टेल कहीं पे टेल नजर आ रही है इस डिस्ट्रीब्यूशन की? वेयर यू कैन सी द टेल ऑफ the tail is on the right side. So you can see here the distribution is abruptly stopped. However, here you can see the distribution is not abruptly stopped and it continues and forming a tail. So it was the tail on the right side. Obviously, the skew is on the right side. Where the tail goes, the skew goes. So weight. Can you appreciate that it is really beautifully distributed? Still a bit on the right side because we had few participants with very high weight, body weight, but still it is very good. For the height and for the BMI. And here you can see the tail is going on the left side compared to the right side, and the BMI was left skewed. But for you people, this data is so beautifully following the normal distribution parameters that you may find difficulty detecting where the skew is, because you may be learning these concepts right now. All right, and this was diastolic, right? So any question? I can take question. I have 5 minutes, 5 more minutes. Yes, sir. 80 maybe. Yeah. So Whenever you do research, what is the end note from my side for you? If you are interested in doing research, you should study it hard, find your literature, make a good topic, and then your objective, and then your um, methods of data collection must be good. Your machines which you use for example, measuring height or weight must be very good without error or minimal error, because there is an inbuilt error in all the machines. So you must use a machine which has minimal error, and you must check your machine daily or periodically, so that your machines, whatever the machine is, a machine could be a thermometer, a weighing machine, or a blood pressure apparatus, a sphygmomanometer, or any other type of machine that you are using. Anything else? Anis or Oves, are you there? Anis, Mr. Anis, are you there? Thank you very much for patient listening and participating with me, interacting with me. Although the number of participants were not that good, I mean you were good, but not the size of this group was good. But we had a good discussion, and I hope you grasp the concepts. You must read it from your book. You can use the book of community medicine by Muhammad Ilyas, or J.E. Park by an Indian author on community medicine. Or there is another book I can recommend you if you have more passion towards numbers, stats, arithmetic, and research thing. That the book is by Aviva Petri. Aviva Petri. The name of the book is Medical Stats at a Glance. I usually recommend this book to the students, both undergrad and postgrad, because it is easy to understand, and the good thing is it is based on SPSS. So most of the analysis that they have shown is from the SPSS output and SPSS software, right? So this was the book, Aviva Petri. Yeah. All right. We are ending this session here. Good luck for your exams and modules, and we'll come back with a new lecture in the Biostat series sometime later. Allah Hafiz.